Hello viewers, welcome to my channel. I'm Hasham. So far 15 problems I have completed on transportation. This is the last and final video on the problems. So earlier I have explained you all the problems regarding minimization. That means some objective, the cost, the distance, the time has to be minimized. So in those cases, the procedure what we have done earlier, that will be applied. But in this problem, the new concept is maximization problem. So how to find the scheduling of transportation in order to maximize a certain variable. The variable is profit. So normally cost should be minimized, the losses should be minimized, but the profit should be maximized. So this is the first and only one problem I am going to explain you how to solve a maximization problem in transportation. So before starting the 16th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep it ready. Take the screenshot of the points which I have written on the board, then I'll explain every point in detail. Now, see the last problem, 16th one. Solve the following transportation problem for maximum profit. Concentrate on the word maximum profit. So, our objective is to maximize the profit. The profit per unit is given, markets are A, B, C, D. So, destinations are markets. And the sources or origin are the warehouses. So, 3 warehouses are there, X, Y, Z, and 4 markets are there, A, B, C, D. And the profit elements are given 12, 8, 14, 18, 7, 3 like that. And availability at the warehouse, that means supply from the warehouse are X200, Y500, Z300. So total 1000 is the supply. And the demand at the markets are A180, B320, C100 and D400 units. So it's a balanced problem because total supply and total demand both are equal. There is no need to make any dummy row or dummy column, already balanced. Now, the procedure of solving the TP is for minimization type problems. Whatever we have discussed in the previous problems, that procedure is applicable for minimization problem. But this is the first time we are coming across a maximization problem. But in the present problem, it's a maximization type. Hence, we convert it into minimization type. The first job is convert the maximization problem into minimization. How to do that? This can be done as follows. Select the highest profit element. In the matrix, all elements are given. Profit elements are given. See what is the highest profit element. 12, 8, 14, 18, 7, 3, 6, 10, 11, 25, 18, 20. So you can see the highest element is 25. Select that element. Subtract all the matrix element from that highest element. From that highest element of 25, subtract all the remaining elements. The reduced matrix is called opportunity loss matrix. So if you subtract all the elements from the highest element, the reduced matrix is called opportunity loss matrix. The problem will be converted for maximization type into minimization type. This is the only procedure for converting the problem from maximization to minimization. Here, the table, opportunity loss table. In the problem, the table is given profit matrix table. I have converted it into opportunity loss. How? The maximum element is 25. The first element 12. So 25 minus 12, 13. So I have taken 13 here. Second element is 8. So 25 minus 8, 17. Here I have taken 17. Next element is 14. So 25 minus 14, you will get 11. In this way, all the elements in the given matrix are subtracted from 25. This is the matrix we got. The total availability, total demand. That's all. Now we proceed to find out IBFS, Initial Basic Feasible Solution by VAM. Vogel's approximation method. So we need row penalties and column penalties. I have prepared the table as usual. Every problem from first problem onwards we are doing the same thing. This is the VAB method. So upper right corner I have taken all the costs 13, 17, 11, 7, 8, 22 like that, and demand and supply. Now I am going to start the penalties. Penalty is the difference between the smallest cost and the next smallest cost. In the first row the smallest cost is 0. The next smallest cost is 7. 7 minus 0, 7. Here the smallest cost is 7. The next smallest cost is 15. So 15 minus 7 is 8. Here the minimum cost is 5. Next minimum is 11. So 11 minus 5 is 6. Row penalty is completed. Column penalty. Minimum is 11. Next minimum 13. So 13 minus 11 is 2. Here minimum is 7. And next minimum is 18. So 18 minus 7 you will get 11. Right? Here minimum is 14. Next minimum 15. So 15 minus 14, 1. Here minimum is 0. Next minimum 5. So 5 minus 0, 5. Now we have calculated the penalty row and penalty column. Select the highest penalty. 7, 8, 6, 5, 1, 11. So 11 is the highest. Circle it. In which column we are getting 11? B column. Minimum cost in this column 7. Fill up this cell. The row total is 200, column total is 320. Whichever is less. 200 is less. So I am allocating 200 here. This will become 0. And 320 minus 200 you will get 120 remaining. Now row has become 0. So the row will be blocked. As usual. The first row is blocked. Now I am coming to the second penalty. First row is blocked, put a dash. Second row minimum 7. Next minimum is 15. So 15 minus 7 is 8. Here minimum 5. Next minimum 11. 11 minus 5, 6. Column wise, minimum 11. Next minimum 17. 17 minus 11 is 6. Here 22 minus 18 is 4. Here 15 minus 14 is 1. 7 minus 5 is 2. Now see what is the highest penalty in the second penalties. 8, 6, 2, 1, 4, 6. So 8 is the highest. I am rounding off this 8. In which row we are getting this 8? Y row. What is the minimum cost? 7. So I am going to fill up this cell. Row total 500, column total 400. So I will take 400 here. Then 400 minus 400, 0. 500 minus 400 is 100. The column is exhausted. So block the column. Third penalty. First row dash. Second row minimum is 15. Next minimum 17. So 17 minus 15, 2. Here 11 to 14. So 14 minus 11 is 3. Column wise 17 minus 11, 6. Then here 22 minus 18, 4. Here 15 minus 14, 1 dash. Now see what is the highest penalty in the third case. Dash 2, 3, 1, 4, 6. So 6 is the highest. Let's make it a circle in 6. Which column? First column. What is the minimum cost here? 11. So I will fill up this cell. The row total 300, column total 180. So I will allocate 180 here. This will become 0. Here 300 minus 180 remains 120. Right? Now column is blocked. Now block this column. That's all. Next penalty. Fourth penalty. First row dash. Second 18 minus 15, 3. Here 22 minus 14. So 22 minus 14 is 8. Right? Now column wise, first column dash. Second column 22 minus 18 is 4. Here 15 minus 14, 1 dash. Now what is the highest penalty here? 8. Round off this 8. What is the minimum cost here? 14. So row total 120, column total 100. So I am allocating 100 here. This will become 0. Here remains 20. Now this column is blocked. The column is blocked. Now we don't require any other penalty, because if any row or column is having only a single unoccupied cell, we can take the balancing figure. So in the Y row, second row, you can see only one unoccupied cell is there in row. So what is the row total here? 100. So I'm allocating 100 here. So this will become 0, and 120 minus 100, you will remain 20. Now you can see only one unoccupied cell is there, where row total is 20, column total is also 20. Now allocate 20 here. This will become 0. This will also become 0. Now you can see all the cells are either occupied or blocked. There is no empty cell. That means we have reached the solution, IBFS solution. Now find out the total of demand and supply. All must be equal to 0. 0, 0, 0. Here also all zeros. That means we have correctly made the IBFS according to M. The next step is whether this IBFS is non-degenerate or not. Number of allocations must be equal to M plus N minus 1. After this, you should write down here. The number of allocations are 1, 2, 3, 4, 5, 6. So 6 allocations are there. And M plus N minus 1. M plus N minus 1. Number of rows. How many rows are there? 3 rows. Plus how many columns are there? 4. Minus 1. 3 plus 4, 7. 7 minus 1, 6. So M plus N minus 1 is 6, and number of allocations are also 6. That means the IBFS is non-degenerate. Now we can proceed to find out the optimum solution by UI and VJ method. So for that we require this table. In this table, same thing. First of all, I will take the allocations here. The allocations are 200. Here I am taking 200. Then next 100. 100. Then 400. Next comes 180. Right? 20. Then 100. These are the allocations we got from this VAM IBFS. The same allocations are copied. Now once we check whether our allocations are right or not, column wise 180, total 180, 200 plus 100 plus 20, 320, the 100, here it is 400. So row wise 200, then 500, 180 plus 20, 200 plus 100, 300, correct allocations. Now any one of the U value, we have to take it 0, either U1 or U2 or U3. So what I have taken is, in the third row we have 3 allocations. So I am taking U3 is equal to 0. So U3 is equal to 0. Because anyone you can take, either U1 you can take, you can take U2 or U3, anyone. But by 3 allocations are there, that's why directly I am taking here, because without any calculations I will get V1 value. V1 value will be 11. V2 value will be 22. And V3 value will be 14. So directly whatever is Cij, the same amount will be V1. The other values of V4 and U1, U2 and U1, that can be obtained by using the formula Cij is equal to Ui plus Vj. For example, this is the occupied cell. By using this cell, I can be able to get the value of U2. What is the location of this cell? Second row, second column. So C22 is equal to U2 plus V2. U2, C22 how much? 18. U2 we don't have, but V2 we have 22. Bring the 22 to LHS, so minus 22. So 18 minus 22, you will get minus 4. So U2 is equal to minus 4. Bring 22 to LHS, so 18 minus 22, you will get minus 4. So here I am taking minus 4. Now by using this cell, I can be able to get the value of V4. What is the location? Second row, fourth column, 2, 4. C24 is equal to U2 plus V4. How much is C24 here? 7. is equal to U2. U2 is minus 4 plus V4. Bring the minus 4 to LHS. It will become plus 4. So 7 plus 4 is 11. So V4 is equal to 11. Here we got 11. Lastly, by using this cell, we can be able to get the value of U1. What is the location? First row, second column, C12. C12 is equal to U1 plus V2. No, U1 plus V2, correct. So C12 how much? 7. 7 is equal to U1 plus, how much is V2 here? 22. That means bring 22 to LHS. So it will become minus 22. So 7 minus 22. So 7 minus 22 you will get minus 15. So we got U1 is equal to minus 15. We got here minus 15. That's all. We have calculated all the UI and VJ values, right? Now we need the opportunity cost of unoccupied cells as usual. The opportunity cost of unoccupied cells can be ascertained by using the formula delta Ij is equal to Cij minus Ui plus Vj. So what we will do is, without even you can substitute the values and get the answer of opportunity cost. Alternatively, orally I will explain you. Cij, from Cij subtract Ui plus Vj. How much is Ui here? 11. Ui is minus 15 and Vj is 11. So 11 minus 15 is minus 4. 11 minus 15 is minus 4. So 13 minus minus 4. Minus into minus will be plus. So 13 plus 4 is 17. So here I will get 17. Otherwise I'll show it in calculations. Delta Ij. So here delta first row first column delta 11 is equal to C11 minus U1 plus V1. So C11 cost of first row first column 13 minus U1. U1 is minus 15 plus V1. V1 is 11. So 13 minus 15 plus 11. You will get minus 4. So in bracket you will have minus 4. So minus into minus will become plus. So 13 plus 4 is 17. So by substituting the values we are getting 17. Without applying that in the formula directly we can take it here 17 like this. Similarly here Cij is 19. Ui is minus 15. Vj is 14. So 14 minus 15 is minus 1. So 19 minus minus 1, minus into minus plus 1. So 19 plus 1, 20. Now I am coming to this one. 0 minus 11 minus 15. 11 minus 15 is minus 4. So 0 minus minus 4, minus into minus plus. So 0 plus 4 is 4. Similarly here, 17. So 11 minus 4. So 11 minus 4 is 7 plus 7. So 17 minus 7 is 10. This cell. 14 minus 4 is 10. So 15 minus 10 is 5. Right? Last cell. This one. Now here 5 minus 11 plus 0 is 11. So 5 minus 11. 5 minus 11 is minus 6. 5 minus 11 is minus 6. So one opportunity cost is negative. So these allocations are not optimum solution. If all the opportunity costs are positive, we reach the optimum solution. Here all the opportunity costs are not positive. One opportunity cost is negative. One opportunity cost negative, not optimum. We have to change the allocations. How to change the allocations? In the previous problem also 2-3 problems I have explained you. Start a loop from the cell where we have negative opportunity cost. This is negative opportunity cost. From here I am starting the loop. You have to make a loop in square or in rectangle where every turning must have 90 degrees, and whenever we are taking the turn, there should be occupied cell. Whether you can go clockwise or anti-clockwise. So here I am going anti-clockwise. Anyway you can go from here to here. From there I will take the left turn to here. Then I will come down to this one. Then I will go back to home. We can skip like this, back to home. This is called the loop. Now we put the positive and negative points, starting positive with from the home. Home is this one. We are taking positive. Here it is negative. Here positive. Here negative. Alternative positive, negative will take. Now negative sign and allocations. Here negative sign 400 allocations. Here negative sign 20 allocations. The minimum allocations are 20, right? Now 20 we reallocate in this loop. Wherever positive sign is there, add 20. Wherever negative sign is there, subtract 20. Like this we change the allocations in this loop in the next table. So there is one negative opportunity cost, that is in this cell, -6. So we are starting the loop either anti-clockwise or clockwise. Anyway we can go. But I have taken anti-clockwise from here to 400, 400 to 100, 100 to 20. Now I am skipping this 100 and coming back home. This is called the loop. Now put alternative positive, negative. The cell from which we are starting the loop, positive, then negative, then positive, negative. Now negative sign and see the allocations. Here the allocations with negative sign 400, here negative sign 220. So which one is less? 20 is less. So we reschedule 20 in this loop. That means wherever there is positive, add 20. Wherever there is negative, subtract 20. Keep the other allocations as it is. So other allocations 200. So I have prepared this table. After that table, I have prepared this table. So in this table, the other allocations 7th. This is 200. So same 200 I have taken. This 100. Same 100 I have taken, right? 180, same 180, because there are no changes in these allocations. The changes will be there only in the loop. So how I am going to take, in this cell, it was empty earlier, now plus 20. So I am making here plus 20, where? In this cell. So here 20 allocations, right? Now here 400 was there. So 400 minus 20, 380. So here I am taking 380, right? Then here plus, the 100 plus 20, it will become 120. So here it will be 120, right? Here it was 20 earlier. Now 20 minus 20 will become 0. So no allocation in this cell. Now after changing the allocation, see whether the total supply and demand is same or not. The total 180, 200 plus 120, 320, here 100, 380 plus 20, 400. So column wise it's correct, row wise 200, 120 plus 380, 3, 4, 500. Then 180 plus 20, 200, 200 plus 100, 300. Exactly correct, right? Now again we have to calculate the UI, VJ value and opportunity cost. First let U3 be 0. I have taken U3 is equal to 0 because 3 allocations are there. So directly we will get the V1 value. What is the V1 value here? 11. Here V3 value is 14 and V4 value is 5. So without any effort, we got the value of V1, V3 and V4, right? The other values of UI, VJ can be calculated by using the equation Cij is equal to UI plus Vj, as usual. Now we will take up which cell? Here, this cell. Because, no, we can't take this one. We will take this one. What is the location of this cell? This cell location is second row, fourth column, 2, 4. So C24 is equal to U2 plus V4. How much is C24 here? 7. 7 is equal to U2. We don't have U2. plus V4. V4 is how much? 5. That means take the 5 to LHS. So plus 5 will become minus 5. 7 minus 5 is 2. So U2 is equal to 2 we got. Right? Now we'll make use this cell to find out the value of V2. What is the location? 2, 2. C22. C22 is equal to U2 plus V2. How much is C22 here? 18 is equal to U2. U2 is 2 plus V2. So we got V2 value. Take this 2 to the LHS. So 18 minus 2. Plus will become minus if we take it to LHS. So 16. 18 minus 2? 16. So V2 is equal to 16. Here we got 16. Now finally we want V1, U1 value. What is the location of this cell? First row, second column, C12. So C12 is equal to U1 plus V2. How much is C12 here? 7. So 7 is equal to U1. We don't have. But V2 we have 16. So U1 is equal to, take this 16 to LHS. So 7 minus 16 is minus 9. Minus 9. So 9, 10, 16, correct. So we got minus 9 U1. Here we take minus 9. That's all. We got all the values of UI and VJ. Now we can easily calculate the opportunity cost of unoccupied cells. That is delta Ij is equal to Cij minus UI plus VJ. So first, how much is the Cij here? Cij 13, right? 13 minus UI plus VJ, 11 minus 9. 11 minus 9, that is 2. 11 minus 9 is 2. So 13 minus 2 is 11. So here we got one opportunity cost 11. Similarly in this cell, the Cij is 19. UI plus Vj, 14 minus 9. 14 minus 9 is 9, 10, 11, 12, 13, 14, 5. Right? So 19 minus 5 is 14. So again we got positive opportunity cost. Now 0 minus 5 minus 9. 5 minus 9 is minus 4. So 0 minus minus 4, it will become plus 4. Again positive. Again positive sign. Here 17. So 11 plus 2. 11 plus 2 is 13. So 17 minus 13 is 4. Here 15. So 14 plus 2, 16. So 15 minus 16 minus 1. Again we are getting a negative opportunity cost. So again one more table is required. Now this 16 plus 0 is 16. So 22 minus 16 is 6. Positive. Right? Now over. Finished. All unoccupied cells we have calculated, but we got one opportunity cost as negative. So these allocations again are not optimal. One more iteration we have to make. Now start to make a loop from the cell where we have negative opportunity cost. So here negative opportunity cost is minus 1. So I am going to make here from here, I am going to make the loop. Either clockwise or anti-clockwise. I'll go clockwise. So here, from here I will go to right 380, down 20, then 100, then again come back home. So this is the loop. Now positive, positive, negative, positive, negative. So alternative signs, positive, negative. Now consider the negative signs and minimum allocations. So two negative signs are there. One negative sign 380, one negative sign 100. So 380 or 100, whichever is less. 100 is less. So we change the loop by shifting 100 units. Positive sign add 100, negative sign subtract 100 in this loop. Whereas the other allocations will remain same. So I will take down the other allocations. This is the next table. So here 200. This is same. No change. right? And this is 120, no change. Then this is 180, no change. 3 allocations, no change. Only in this loop we are making the change. So here 15th plus 100, because 100 and 380, whichever is minimum, 100. So I will take 100 here, right? So 380 minus 100, you will get 280. Here I will take 280, right? Here 20, 100 plus 20 is 120. Here 100 minus 100 will become 0. No allocation in this cell. That's all. After making the allocations, check whether our total demand and supply is same or not. Vertically, 180, 200 plus 120, 320, 100, 2, 3, 400, right. So columns are correct. Row wise, 200. So 120 plus 280, 2, 3, 4, 5, 500. 180 plus 120 is 300. Correct allocations. All the demand and supply are satisfied. Now again we have to take any one of the u as 0. Now I am taking u2 is equal to 0 because 3 allocations are there in this row. So u2 is equal to 0. So here 18, here it is 15, and here it is 7. 3 values directly I got. Now other values of ui and vj we can get by using the equation Cij is equal to ui plus vj, right? Now for occupied cells, this cell, if we make this cell, we can be able to get u3. So what is the location? 3, 4. C34 is equal to u3 plus v4. How much is C34 here? 5. So 5 is equal to u3 plus v4 is 7. Now take this 7 to LHS. So 5 minus 7 is minus 2. So u3 we got minus 2. Now make use this cell to find out the value of v1. 3, 1. C31 is equal to u3 plus v1. How much is C31? 11 is equal to u3 is minus 2 plus v1. Right? So take this minus 2 to LHS. So it will become plus 2. So 11 plus 2, 11, 12, 13. So v1 is equal to 13. That's all. Now one more cell. This cell will make use to calculate u1 value. What is the location of this cell? First row, second, 1, 2. C12 is equal to u1 plus v2. So how much is C12 here? 7. 7 is equal to u1. u1 we don't have. Plus v2. v2 is 18. Then what will happen? Take this 18 to LHS. So 7 minus 18 is equal to u1. So 7 minus 18. So minus 11, that is equal to minus 11, right? So we got u1 value minus 11. That's all. We got all the ui and vj value. Now we can easily calculate the opportunity cost of delta ij. Delta ij is equal to Cij minus ui plus vj as usual for unoccupied cells. This is unoccupied cell. Cij is 13. Now add up ui and vj. 13 minus 11. 13 minus 11 is 2. So 13 minus 2. Because if you have to add up ui and vj. So 13 minus 11. You will get 2. So 13 minus 2. You will get 11. One opportunity cost we got positive. Next here. 15 minus 11 is 4. So 19 minus 4 is 15. Here 7 minus 11 is minus 4. 0 minus minus 4. Minus into minus will become plus. So 0 plus 4 is 4. Here 17. So 13 plus 0 is 13. 17 minus 13 is 4. Now this unoccupied cell. 22. 18 minus 2 is 16. 22 minus 16 is 6. Here 15 minus 2 is 13. 14 minus 13 is positive. Fortunately, we got all opportunity costs are positive. We reached the optimum solution. So these allocations are the optimum allocations. No further improvement is required. And even if you change the allocations, then the total transportation cost or total profit will decrease. Our problem is maximizing the profit. So if we make these allocations, our profit will be maximum. If we change the allocations, the profit will not be maximum. Now allocations. Now I am writing the allocations here. What are the allocations and what is the total transportation cost? Here I am taking allocations, then units, cost per unit and total cost, right? As usual, the first is X to B. X to B, how many units? 200 units, 7 rupees. Then Y to B. Y to B, 120, 18. Then Y to C. Y to C is 115. Then next one is Y to D. Y to D is 280 into 7. Sorry, the problem is regarding the profit per unit. It is not the cost, it is the profit, total profit. Now we should not take this. We have to take the profit element from the original problem. So Y to D over next Z to A. Z to A, how many units here? 180. Last one, Z to D. Z to D is how many units? 120 units. If you take the total, you should get 1000 units. Now here total cost. Now how to find out the profit? Now see here. We have to refer back to the original problem for getting the profit per unit. So here X to B, the profit is 18 rupees. We should not take these. These are the opportunity cost. Simply to find out the allocations, we have converted into opportunity cost. Once we got the allocations, we'll go to the original problem to take the profit. So 18, Y to B. Y to B it is 7. Then Y to C. Y to C it is 10. Then Y to D. Y to D it is 18. Then Z to A it is 14. And Z to D it is 20. That's all. These are the profits per unit. Now we have to multiply. 200 into 18, you will get 3600. Then 120 into 7, you will get 840. Then 100 into 10, you will get 1000. 280 into 18, 280 into 18, 5040. Next one, 180, 14, 180 into 14, you will get 2520. Last one, 120 into 20, you will get 240, 2400. That's all. Now simply you add up 3600 plus 840 plus 1000 plus 5040 plus 2520 plus 2400. It comes to 15,400. This is the total profit. Total maximum profit is 15,400 if you make these allocations. If you change the allocations, the profit will decrease. This is the maximum profit. Now check whether the total units are 1000 or not. 200 plus 120 plus 100 plus 280 plus 180 plus 120. You got 1000. That means our calculations are correct. So this is the end of 16th problem, and that is the last problem on transportation. So if you want the perfect knowledge, if you want to get the complete command on this topic of transportation, watch all the videos. Don't skip in between. It requires a lot of patience, lot of hard work. Then only you can be able to get the command on these problems. Particularly operational research subject is a tough subject. It requires a lot of practice. When you watch the video, when you listen the lecture, only 50% of your preparations will be over. Other 50% your practice. So if you have not watched the earlier videos, go to the playlist of my channel, select the subject operation research, select the videos of transportation, watch the theory videos, be perfect about the concept, start the initial videos to see how to find out the IBFS, then optimum solution. So this is the end. If you are satisfied, give a like to the video, share my channel among your friends, among your groups, so that more students can watch the video and enhance the knowledge. Subscribe my channel if you have not yet subscribed, and by the super thanks which is given below my video. Inshallah, we'll continue the next topic in the next video.